In recent days, photos have shown that the domestically produced Z-10H armed helicopter is being returned to the factory for an upgrade. This image has evoked a great deal of emotion. The domestically produced engine has achieved replacement of the imported engine, and the Z-10 armed helicopter has completely broken free from foreign engines. In the 1990s, based on the development trends of advanced armed helicopters abroad, we decided to develop a domestic armed helicopter. In 1998, the domestic Z-10 armed helicopter project was launched. Considering the high requirement for plateau performance of the domestic armed helicopter, but the development of the domestic turboshaft engine was still in progress, we decided to use imported engines first, and replace them with domestic engines after they mature. The domestically produced Z-10 attack helicopter has a maximum takeoff weight of 6 tons. Based on this specification, we selected the Pratt & Whitney Canada PT6C-76 turboshaft engine with a takeoff power of 1,200 kilowatts. In the case of a maximum takeoff weight of 6 tons, the Z-10 attack helicopter has a takeoff power-to-weight ratio of 0.4 kilowatts per kilogram, ranking first globally. The advanced armed helicopters from abroad, such as the familiar Apache, have a takeoff power-to-weight ratio of only 0.27 kilowatts per kilogram, while the European Tiger armed helicopter is also only 0.32 kilowatts per kilogram. Due to the low takeoff power-to-weight ratio, the Apache armed helicopter is known for its high-altitude heart disease. In April this year, an Indian Army Apache armed helicopter was training near the China-India border, and as a result, the engine was not adapted to the high-altitude environment and malfunctioned, forcing the helicopter to make an emergency landing. The Indian Army found that the Apache armed helicopter was unable to move, and in the end, they had to dismantle this Apache armed helicopter and transport it down the mountain by truck, becoming a laughingstock. The successful first flight of the domestically produced Z-10 armed helicopter took place in 2003, with an original plan to enter service in 2005. However, after learning that the Z-10 was equipped with a Canadian engine, the United States immediately exerted heavy pressure on Canada, demanding that it cut off the supply of engines. Canada was unable to withstand the pressure from the United States and cut off the supply of engines to China. We have no choice but to put the domestically produced WZ-9 turboshaft engine into emergency operation. However, the WZ-9's takeoff power is only 1,000 kilowatts, so the takeoff power-to-weight ratio of the Z-10 attack helicopter will drop to 0.32 kilowatts per kilogram. Although this performance is still better than the Apache, it can still meet our needs in most environments. However, considering the high-altitude operating environment, this indicator still cannot support the Z-10 in carrying out combat missions on plateaus. In this case, we carried out weight reduction design on the Z-10 armed helicopter, which includes the cancellation of protective armor, simplification of the optoelectronic system, and the lack of a complete onboard auxiliary defense system. After these designs, the takeoff weight of the Z-10 armed helicopter was reduced, and the thrust-to-weight ratio was restored, ensuring the high-altitude mission capability. Of course, the price paid is that the battlefield survivability of the Z-10 armed helicopter has decreased, and the upgrade potential has also been greatly limited. The Z-10 armed helicopter was commissioned for service in 2010, and before that, we had also pre-produced a small batch of Z-10 armed helicopters for delivery to the troops for pioneering use, which were called the Z-10H. Through our efforts, we have broken through a series of advanced technologies, including single-crystal high-pressure turbine blades, integral turbine discs, and a full-authority digital engine control system. Utilizing these technological achievements, we have made major improvements to the WZ-9 turboshaft engine, including the use of more advanced materials, higher turbine inlet temperatures, and more advanced compressors to improve intake efficiency. According to external information, the improved WZ-9 engine has a power output of 1,200 kilowatts, catching up to the PT6C-76 turboshaft engine. The Z-10H armed helicopter has been in service for more than 10 years since 2024, and it is now time for a major overhaul and upgrade. This time, the Z-10H is being sent back to the factory for a comprehensive overhaul, with the installation of the domestically produced WZ-9 improved engine, an upgrade of the avionics system, and new weapon systems. It is speculated that the Z-10H will be equipped with the WZ-9 improved engine, and the airframe will receive additional protective armor. The helicopter will also be fitted with a new generation electro-optical sighting system, and its weapons will be replaced with domestically produced next-generation anti-tank missiles and precision-guided rockets. The onboard countermeasures system will be enhanced with a directed energy system to jam and suppress new-generation air defense missiles. The communication and data link systems will be upgraded to a new high-speed broadband data link, which will also enable improved unmanned aerial vehicle control capabilities. After such an upgrade, the performance of the WZ-10 armed helicopter has been greatly improved, enabling it to adapt to the battlefield environment after 2030 and serve as a transitional force before the next generation of armed helicopters enters service.